This video is going to review solving different types of equations. I think we're most familiar with solving linear equations, so I'm not going to say too much about that, except that's when we solve for x, and our answer usually looks like this. For absolute value equations, we need to make sure before we can solve anything, we need to make sure that we isolate the absolute value. So notice I'm going to actually subtract 7, and then after I do that, I'm going to divide by 2. So when I subtract 7, I get 6, and when I divide by 2, that's how I'm getting the 3 that I have right here. Now that I have the absolute value isolated, then I can separate and get two answers, meaning that the absolute value, which is right here, can either be a positive 3, or what's inside, which is the 4x minus 3, can be a negative 3. And notice I have two linear equations, and we should be able to solve that. Looking at quadratic equations, we can have something that's in the form of 6x squared plus 7x is equal to 3. In order to solve them, though, we need to make sure that we set it equal to 0. So all I did was subtract 3 from both sides. Once we do that, we can start using the zero product property, which means I'm going to factor the 6x squared plus 7x minus 3 and set it equal to 0, and then let each of the factors equal to 0. That's usually when we end up with two parentheses. We set each of those parentheses equal to 0. And again, most likely these are linear, so it goes back to being able to solve a linear equation. We'll discuss more about how to solve by completing the square because we're going to use that method in the course, but for right now I'm going to skip that method, and then the other one that most people are familiar with is the quadratic formula, and here's the quadratic formula to remind you of that. Now I know I skipped it on purpose, and that is this first one that talks about the square root property. This one is a special case. It's when you have something that looks like x plus 3 and that is squared, and we have that equal to a particular number, let's say 12. Then what we can do is take the square root of both sides, and that's going to give me x plus 3 because the square root of something squared is just that thing. And then on the other side we're going to have the square root of 12. But don't forget that when we take the square root, we actually have plus or minus. And then we can start solving. We'll see that x is equal to negative 3 because I subtract 3 to both sides, plus or minus the square root of 12. And that's very similar in terms of a format of that's given by the quadratic formula. So that's just another tidbit on how to solve quadratic equations. Quadratic-like equations are equations in which we can use quadratic methods to solve. So let's say we have an equation that looks like this. Now we can go on ahead and try to multiply everything out and then try to factor from there. Our problem's going to be that it's going to take a lot of time. So let's use a u substitution. We're going to let u equal to the quantity of m plus 3 squared. And that's usually this guy right here in the middle. So I just wanted to make sure that that's usually where you find it. Because if I square it, notice that when I square it, I'm actually going to get the quantity of m plus 3 to the 4th power, which is what we have right here. So by substitution, I'm going to say that this quantity of m plus 3 to the 4th power is the same thing as u squared. And this quantity of m plus 3 squared is the same thing as u. So we're going to put that right there. And then I still have the minus 2. Now we have a quadratic equation that we can solve. Notice here, I already have it set equal to 0, so I factor it, and then I let each of the factors equal to 0, and that's how I solved for u. But remember, this equation is actually in terms of m. So now I have to solve for m. So I'm going to undo my substitution and change this u into m plus 3 squared, and that's what I'm doing right here. And then to get rid of the square, I'm taking the square root. That's one of the properties that we talked about when we were talking about quadratic equations. But don't forget to do plus or minus. On the left side, we see we just get m plus 3. And on the right side, we're going to get the square root of negative 1. Remember, that is complex, so that's going to be I, or imaginary. So I have plus or minus I. And again, solving for m, I find my two solutions here. Likewise, I do the same thing for the other value of u. Continuing on the next page, we see that we're going to talk about solving rational equations. Remember, the word rational comes from the word ratio, which means that we're looking at fractions. So when we have fractions, so our original equation is x over x minus 2 is equal to 2 x over x minus 2 plus 2. So when we have fractions, the first thing we need to make sure is that it's always defined. So we always look at all the denominators. In this case, it's just x minus 2. And we want to make sure that they're not equal to 0. Because if they are, then we're going to have a fraction, some number over 0, which is undefined. So what we're doing now is we're just going to solve and find that x cannot equal to 2. And that's what we call a domain restriction. So that's where this one is coming from. So now I'm going to multiply my equation, every term, by my least common denominator. So that's when I look at all the denominators and see how I can make them all the same. So I'm going to multiply, and that is going to be the x minus 2. So I'm going to multiply the x minus 2 times every term. So we can see in the first fraction that the x minus 2's cancel out, and that's how I end up with just an x. I do the same thing for the second term. The x minus 2's cancel out, and I just end up with a 2. However, in the last term, nothing cancels out, so I actually end up with both of those 2 times x minus 2. And notice this is now a linear equation. And we talked about how we should be able to solve linear equations. We're solving for x, so we're going to do all the work, and we're going to find that x is equal to 2. That sounds great, except that we need to make sure we check with our domain restriction, and we see that the only thing the x could not be was 2. The only answer we found was 2, so therefore we're going to have no solution for this particular problem. In radical equations, this is when we have a radical symbol. So in order to solve this one is very similar to the absolute value, where we're going to have to isolate the square root or the radical. So I am going to add x to both sides, and that's how I end up with x plus 1. And on this side I end up with the square root of 2x plus 3. So I want to get to x, so I'm going to square both sides. Notice I've put one set of parentheses on the left so I can square it, one set of parentheses on the right so I can square it. We know what happens with the square root and the square. They kind of cancel each other out, and I end up with just 2x plus 3 on the left. However, on the right side, remember that I'm getting my x plus 1 and I'm squaring it, so I'm going to do x plus 1 times x plus 1. And that's the reason why I wrote the word FOIL, to remind you that you actually have to multiply those two binomials, and that's how you get x squared plus 2x plus 1. And this is now a quadratic equation. Remember, what we're going to do here is we're going to set it equal to 0 and see if we can factor or use the quadratic formula. Again, we need to check our answers, because we need to make sure that when we're trying to take the square root of something, that this 2x plus 3 is a positive value. Otherwise, we get into imaginary numbers. The last two types of equations I want to discuss are exponential equations and logarithmic equations. They go hand in hand because they are inverses of each other. So let's first talk about exponential equations. So let's say we have something that looks like this. Well, one of the easiest way to solve is that if we have the same base, then we can say that the exponents are equal to each other. This is one of our properties of exponents. So I have a 2 here, and I have 1 over 16, but what I do know about 16 is 2 to the 4th. So I can have that same base of 2. But notice 2 to the 4th is 16, but I want 1 over 16, and that's where I'm getting that negative 4, as you can see here. So now that I have the same bases, then I can say that the exponents are equal to each other. And that's where I get this equation. And here we have another linear equation that we should be able to solve for x. Under logarithmic equations, I want you to notice that we have log of base 3 of 4x minus 1 plus log of base 3 of x is equal to 2. So one of the things that we want to do is to make sure we only get one log. So we're going to combine these two by using the property that says that if you have the log of whatever base of, let's call it x, and you're adding another log of the same base, let's call that y, then that's the same thing as getting the log of the same base and multiplying the x and the y. If this had been minus, then we would be dividing, but it's the same idea. So with that, now you can see why I end up with just this one log, and I'm multiplying the x from here and the 4x minus 1 from over here. I still have the same base. Now that we have that, I'm going to use this great fact that the conversion between logs and exponents. See, I don't know how to solve this in terms of base 3. What I can do is change my log into a base equation and see if I can use the same base. So notice this is our base is 3. This is our exponent, and that's why we're getting 3 squared is equal to our answer. And that's what this cloud is saying. So that's why we have this, and notice we're going to multiply this side, and that's how we're going to get quadratic. So then from here we're going to solve a quadratic equation, and then we need to make sure we check our answers. What we find out is that we cannot take the log of a negative number. It has to be a log of a positive number. So you got to make sure you check answers for that. Finally, you should have a blue handout that has some of these problems that I've been discussing. So try your hand on that. You should also be able to find the answer to this paper on my math lab. And that concludes this video.